A very important test question modeling real life situation. I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a very important communication and application question based on quadratic equations. The question has been taken from previous test paper. Here is the problem. An osprey is a fish-eating bird of prey which dives into the water to catch its food. The height of the osprey above the water t seconds after it begins its dive can be approximated by the function 2t squared minus 28t plus 90, where h of t is height in feet. Part A of the question is, calculate the times at which its height is 24 feet above the water. Part B is, what is the minimum depth of the osprey's underwater dive? We are going to extend this to question number 5C, which is, interpret significance of t-intercept. And question number 5D as, write h of t equals to a times t minus h whole square plus k. So we'll just extend it to two more parts so that we can completely understand the significance of this particular application. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing fairly well, getting highest marks in their class and even scholarships and awards, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us look into the solution of this question. So, part A is calculate the height at which the height of the bird is 24 feet above the water. So, the equation is given to us. Let's rewrite the equation. H of t is equal to 2t squared minus 28t plus 90. Height is in feet, and we want time when the bird's height is 24 feet. So that means h of t is equal to 24. Perfect. So we'll substitute h of t as 24 and solve for t. So on the right hand side, we can actually factor 2 out, right? And then we get t squared minus 14t plus 45. And from here, we can divide 12 by 2. So we get 12 equals to t squared minus 14t plus 45. Let us rearrange, bringing 12 to the right hand side. It gives us 0 equals to t squared minus 14t plus 45 minus 12, right? So let us simplify it. we get 0 equals to t square minus 14t, and 45 minus 12 will give us 33. Now this can be factored. 33 is 11 times 3, and when you add them you get 14. Both negative will give you minus 14. So that gives you t minus 11 times t minus 3. So the time when the height is 24 is actually equals to 11, or it is equal to 3. So our solution is that at time, we can say 3 seconds or 1 second. 3 or t equals to 11 seconds. Let's include units. The height of the bird will be 24 feet, right? So that is how we can answer part A. Now let's look into part B, where what is the minimum depth of Osprey underwater? So when it dives, how do we answer this part? Well, there are a couple of ways to do it. What we can do is we can factor this equation, or we can complete the squares. So strictly speaking, we could do it in many different ways. So I'll show you different approaches. So we'll have strategy 1. In strategy 1, we'll complete the squares. Now, when we complete the squares, we can write this in the vertex form. That was also an extended part of this question, correct? Right, so let's do that. So h of t is equal to, so from this particular equation, we can factor out 2. So factoring 2 will give us t squared minus 14t, and we'll keep this 90 separate. To make perfect squares, I'm using square brackets now. We'll add half of 14 square and subtract that. So we get t square minus 14t plus 7 square minus 7 square plus 90. Adding and subtracting same terms do not really change, and this is the process of completing the squares. So that gives us the first 3 terms as a perfect square, which can be written as t minus 7 whole square, and we have minus 49 here plus 90. Now this is equal to, we can write it on this side. Okay. So we have the height as equal to 2 times t minus 7 whole square. Opening this bracket, 2 times 49 gives us minus 50 would have given us 100, so it is 98 plus 90, right? So we have the height as 2 times t minus 7 whole square minus 8. So that becomes the vertex form of this equation. You can also attribute this to the standard vertex form, which is h of t can be equals to a times t minus h whole square plus k. Perfect, the part which we added. Now this gives you the significance that since it is a positive parabola with positive leading coefficient, the graph will be like this, right? So it hits the minimum, and that is underwater. since it is height is -8, right? Do you see that part? So the minimum is -8, and that really means that the bird actually goes 8 feet underwater. So that is the significance. We can write down our answer here as the minimum which in this case is the depth, is 8 feet, right? So, or you could write the minimum is -8. So we have written the word depth, which means negative. So that is how you could really answer this. And from this equation, you also know when it hits this. So that is an additional part which we added to our question earlier. So this 7 signifies after how long. So this was it, after 7 seconds. So do you appreciate the application and the connection with the vertex form of the quadratic equation? Now, many times we also treat this as a domain and range question, where the range is above -8 in this particular case. Okay, so let's continue. We'll do now second strategy. So now, let's use second strategy to find the minimum. So I'll call it strategy number 2, which basically is that if you have an equation y equals to ax squared plus bx plus c, in that case, the vertex, I should say the axis of symmetry, is at -b by 2a, right? And the value will be at that particular point, correct? So what is the minimum depth? So we can find what is the axis here. So -b by 2a, that means minus of 28 divided by twice 2. So that is minus of -28 divided by 2 times 2, right? That gives you 28 by 4, and that is 7, right? So as we got last time, t equals to 7 in our vertex form. Now, at time t equals to 7, we need to find the height. So we'll substitute in this equation 7. So we get 2 times 7 squared minus 28 times 7 plus 90. You can solve this. 2 times 49 minus 28 times 7, which is 7 times 8 is 56, 5, 14 and 5, 19 plus 90. And this will give you, as we worked out earlier, -8. So we get the minimum using -b by 2a formula. So that gives you a quick solution at times. So hope this is absolutely clear. Perfect. So now, to understand the equation as a whole, this particular function, which is h of t equals to 2t squared minus 28t plus 90, can be written in the vertex form, which we just simplified as 2t minus 7 whole square minus 8. And if you want to interpret this, it will be something like this, that the bird goes like this, right? Where this minimum value occurs at, that is the time, right? And this is the height. and this minimum value is -8, which occurs 7 seconds after. What I would like you to do is to find when does this bird hit the water level. Now these points are called t-intercepts. Since we have taken t as our independent variable, right? So that is the point when bird hit the water level. You get the idea, right? So at this point, height is going to be 0, right? So height is going to be 0. So you need to simplify this and find this particular time. So how do we do that? Let's look into this part. We can bring 8 to this side, right? And then divide by 2. So we have 2 t minus 7 whole square. Dividing by 2, we get 4 equals to t minus 7 whole square. And then we can square root it. So when you square root 4, you have to write plus and minus. And that is equal to t minus 7, correct? Now from here, square root of plus 4, square root of 4 is plus or minus 2. So we get t minus 7 equals to plus minus 2, or time t as 7 plus minus 2. So that gives us two values, correct? One is 7 plus 2, which is 9 seconds. And the other one is 7 minus 2, which is 5 seconds. You get the idea. So the 2 points which we are looking here when it hits the water level is at 5 and 9 seconds. Do you see how we can interpret this equation with quadratic equation and answer so many related problems? Perfect. So it's a very beautiful question. I hope you understand and appreciate it. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.